Welcome, data architects and engineers. Today, we are diving into a powerful Snowflake Cortex AI feature, the summarize function. We will explore how to effortlessly condense massive text datasets into actionable insights directly within your data cloud. Let us get started. Let's begin by defining the summarize function. In today's data landscape, organizations sit on mountains of unstructured text customer reviews, lengthy emails, and operational logs. Extracting value from this requires reading, which doesn't scale. Enter Snowflake Cortex Summarize. It is a pre-built, fully managed AI function that takes a long English language document and condenses it into a concise, coherent summary. Why is this a game changer? Because it brings state-of-the-art large language model capabilities directly to your data. You don't need a team of machine learning engineers to deploy a custom model, and you don't have to write complex Python scripts. You simply invoke it using standard SQL. By leveraging a proprietary Snowflake-managed model, Summarize instantly distills paragraphs of text down to their core essence, empowering your analytics pipelines with immediate, readable insights. Take a look at this flowchart, which illustrates the simplicity of the Summarize architecture. On the left, we have your raw, long, unstructured text, perhaps a lengthy product review. This text is passed directly into the Cortex Summarize function. Behind the scenes, Snowflake securely routes this data to a managed LLM, optimized specifically for summarization tasks. The model processes the text and instantly returns a concise summary output. The beauty of this flow is that it happens entirely within the Snowflake perimeter, ensuring your data never leaves your governed environment. Now, let us look at the implementation. The syntax is elegantly simple. You call snowflake.cortex.summarize, passing in your text column as the single argument. Because it acts as a standard scalar SQL function, you can run it across an entire table containing millions of rows in one swift select query. For example, if you have a table of product reviews, you simply query select summarize, review content, from reviews. The function evaluates each row independently and returns a standard string representation of the summary. This output can be directly materialized into dynamic tables, joined with structured metadata like product IDs or timestamps, and fed directly into your enterprise business intelligence dashboards. It transforms unstructured chaos into structured clarity with literally one line of code. This diagram breaks down the row-by-row execution of the summarize function. When you issue the select summarize command against a column like review content, the Snowflake compute engine distributes the workload. It processes row 1's 500-word review and row 2's 800-word review in parallel. The Snowflake-managed LLM evaluates the semantic meaning of each distinct record and outputs a corresponding one-sentence summary for each. This parallel execution is what allows Snowflake to summarize massive datasets with incredible speed. As senior architects, security and governance must always be our top priority. Snowflake guarantees that using Cortex AI functions does not compromise your data perimeter. Your text data is never sent to external, third-party APIs. It is processed by models running securely inside Snowflake's boundaries. However, because AI functions consume compute credits, access is strictly locked down by default. To use the summarize function, a user's role must be explicitly granted the Snowflake.Cortex user database role. Without this grant, the query will fail. This allows your security administrators to maintain absolute control over which departments, applications, or analysts are authorized to trigger LLM workloads, perfectly aligning your AI strategy with your existing role-based access control framework. Let's map out the security architecture. Starting on the left, the account admin is responsible for granting the built-in Snowflake.Cortex user database role. Once this is assigned to an analyst role, that analyst is now authorized to execute the summarize function. Crucially, look at the final node. All processing happens within the secure Snowflake boundary. There is zero data egress, meaning your highly sensitive intellectual property, customer emails, or financial logs remain completely protected under your existing Snowflake security policies. To build resilient data pipelines, we must understand the technical constraints of the underlying AI models. Every LLM has a context window, a strict limit on the volume of data it can read and write in a single transaction. For the Snowflake-managed model powering the summarize function, the input context window is 32,000 tokens, which equates to roughly 24,000 words. Additionally, the maximum output summary it will generate is capped at 4,096 tokens. If you attempt to pass a massive book or an endless log file that exceeds 32,000 tokens, the function will fail. As a best practice, if you are unsure of your document sizes, you can use the AI Count Tokens helper function to proactively measure your text. This allows you to filter or chunk oversized documents before passing them to the summarize function. This decision tree represents a robust, production-grade pipeline. When a raw document arrives, the pipeline first asks, is the token count greater than 32K? If yes, it branches to a mitigation step where the document is either chunked into smaller pieces or filtered. If no, it proceeds directly to execute the summarize function. Ultimately, both paths converge at the output stage, where the model generates the final summary, bounded safely within the 4096 output token limit. This design guarantees your pipeline will not crash due to unexpected payload sizes. The true power of Snowflake Cortex lies in its composability. The summarize function requires text, but enterprise data often lives in PDFs, slide decks, or audio recordings. You can chain Cortex AI functions together to solve this. For example, you can use AI parse document to extract raw text and layout information from a scanned PDF stored on a Snowflake stage. In the very same SQL query, you can wrap that output in the summarize function. Similarly, if your company records customer service calls, you can use AI transcribe to convert the raw audio file into a text transcript and immediately pass that transcript into summarize. This creates a seamless, serverless pipeline that transforms a folder of raw audio files into a structured table of concise meeting minutes, all without moving a single byte of data out of Snowflake. Let's trace the data flow in a composable AI pipeline. It begins on the far left, where a raw PDF file rests in a secure internal stage. The SQL query invokes AI parse document, which reads the file and extracts the text. Without pausing, that extracted text string is immediately handed off to the summarize function. The LLM processes the text and delivers the final, concise summary string directly into your output table. This sequence illustrates how complex AI orchestration is reduced to a single, elegant SQL statement. As with any cloud service, understanding the economics of AI is critical. The summarize function operates on a consumption-based pricing model, meaning you only pay for exactly what you use. Specifically, Snowflake bills based on the total number of tokens processed. This includes both the input text you send to the model and the output summary the model generates. For the dedicated Snowflake managed summarize model, the cost is highly optimized at 0.10 credits per 1 million tokens processed. To put that in perspective, 1 million tokens is roughly equivalent to 3,000 standard pages of text. To ensure your AI initiatives stay within budget, Snowflake administrators can query the Cortex function's usage history view. This telemetry data allows you to track exactly which teams are running summaries, track daily token volumes, and optimize your overall AI spend. This billing flowchart demystifies the cost structure. The billing engine calculates your usage by summing your input tokens and your output tokens. This total is then multiplied by the highly efficient rate of 0.10 credits per 1 million tokens. The resulting billing metrics are automatically logged into the Cortex function's usage history view. On the far right, your account administrators tap into this view to perform proactive cost monitoring, ensuring complete financial transparency over your AI workloads. Let us solidify this with a real-world enterprise use case: automated support ticket triage. Imagine a global telecommunications company receiving 50,000 highly detailed, often rambling customer support emails every single day. Human agents are spending up to 5 minutes reading each email just to figure out what the customer is complaining about before they can even begin to solve it. To solve this, data engineers build a continuous pipeline. As emails land in the raw tickets table, a Snowflake dynamic table automatically invokes the summarize function on the email body column. Instantly, the 10-paragraph email is condensed into a tight, 2-sentence summary. Now, when the human agent opens the ticket, they read the summary first. This simple AI implementation reduces triage time by 80%, massively improving customer response times and saving the enterprise millions in operational overhead. Follow the sequence of our real-world scenario. The flow starts when the customer email application ingests a long, 10-paragraph complaint into the Snowflake raw table. This insertion triggers a dynamic table, which passes the text to Cortex Summarize. The AI rapidly processes the text and returns a concise, 2-sentence summary back to Snowflake. Finally, this streamlined data is pushed to the agent dashboard. The human agent skips the noise, reads the summary, and solves the problem instantly. To wrap up our training, let's cover critical best practices. First, respect the language constraint. The summarize function is purpose-built and optimized exclusively for English language input text. Passing other languages may yield unpredictable results. Second, maintain data hygiene. Always filter out null values or empty strings in your SQL query before calling the function. Otherwise, you waste compute credits analyzing nothing. Third, understand the scope. Summarize condenses a single string. If your goal is to group 50 different reviews together and generate one overarching summary for an entire product, you should use the AI Summarize HG function instead, which handles multi-row aggregations. By mastering these AI functions, you transform unstructured noise into pristine business value. To master these advanced AI capabilities and ace your exams, I invite you to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. This final flowchart acts as your architectural checklist. As data flows through your pipeline, it hits a data quality check. If the payload is standard English text, it routes perfectly to the summarize function. If the requirement is multi-row aggregation, it routes to AI Summarize HG. If you detect nulls or non-English text, you must route to a filter or perhaps chain the translate function first. Adhering to this routing logic guarantees you deliver optimized analytics every single time. Thank you for watching, and see you at quicktechie.com.